Okay, let's talk about a word you hear all the time in tech, in business, everywhere really, scalable. But what does it actually mean? In this explainer, we're going to cut right through the buzzwords with a new way of thinking about it that might just change how you look at growth, cost, and building for the future.
Do words mean things? I mean, of course they do, right? But what happens when we use a word so much, so often, that it kind of loses its edge? Its meaning gets all fuzzy and watered down. And in the world of tech, there's one word that's a prime suspect.
And that word is scalable. We all use it. We all want our systems to be it. But are we even talking about the same thing? When you're trying to design something, that lack of clarity isn't just a small annoyance. It can be a really expensive problem.
All right, so let's dig in. What does scalable even mean? Before we can land on a better definition, we have to get our heads around why the word is so confusing to begin with.
You know, the biggest issue here is that the word is just all over the place. When someone says their system is scalable, what are they saying? Do they mean it can scale up to handle a sudden flood of traffic? Or that it can scale down so you're not paying for idle resources? Are they talking about beefing up a single server, vertical scaling, or spreading the load across a whole fleet of them, horizontal scaling? This confusion makes it almost impossible to have a clear, productive conversation about how to build things.
Okay, so it's a mess. But what if there's a better way to frame this? A much simpler, much more powerful way to think about it, proposed by AWS engineer Mark Bruker. And it all boils down to one thing we can all understand.
And that brings us to a new definition, one that's all about cost. This completely shifts the conversation away from just technical specs and brings it into the world of economics.
All right, here's the big idea. A system is scalable in the range where the cost of adding just a little bit more work, one more user, one more API call, is approximately constant. The key here is that your cost per thing doesn't suddenly explode as you grow. It stays predictable.
And that right there, that changes everything. Suddenly, scalability isn't just some vague tech buzzword on a feature list. It's a real, tangible business outcome. It's about predictable costs and ultimately sustainable growth. Okay, to really see how this works, let's apply this new definition to 3 super common architectural patterns. We're going to look at the cost shape of each one.
First up, we've got the classic, the single machine. This could be anything, really. A single web server, a database on one box, maybe even just the app on your laptop.
So what does the cost graph look like here? Well, it's pretty dramatic. First, you get this big initial spike. That's the cost of buying the machine. Then, for a good while, the cost to add more work is basically zero, right? The machine's already paid for. But then, you hit the wall. The machine is totally maxed out, and the cost to handle just one more request becomes almost infinite because you need to stop everything and completely re-architect your system.
And let me tell you, hitting that wall when you're not ready for it is a nightmare. Like Mark Bruker says, having to tell your boss, we can't grow the business until we re-architect, that is a really, really bad place to be. That's the pain of a system that isn't scalable.
All right, let's move on to example number 2, the classic multi-machine system. Think about something like a sharded database or an application with a load balancer spreading traffic across a bunch of different servers.
The cost shape for this one, it looks like a staircase. You've got that initial cost to get the first machine and the sharding logic set up. And it's flat for a while as you add work, but then bam, you hit a spike when you need to add another machine. Then it's flat again until you need the next machine. It's definitely more scalable than one box, but your growth happens in these big, chunky, expensive steps. But here's a really important catch. That nice, even staircase, that's the optimistic view. In the real world, if all those machines have to talk to each other and coordinate, the cost of adding each new machine can actually get bigger and bigger over time. The steps on your staircase get taller.
And that brings us to our third and final example, the serverless system. Think of services like AWS Lambda or Amazon S3, where you literally pay just for what you use when you use it.
Now, if we're using our new definition, this is where things get really interesting. The cost shape for a serverless system is basically the holy grail of scalability. The marginal cost is a nearly perfect, predictable straight line. You pay per unit, and that price stays the same whether you have 1 user or 1 million. It scales up smoothly, it scales down smoothly, and the only stairsteps you usually see are actually price drops when you hit certain usage tiers.
Okay, but there's always a trade-off, right? And here it is. With a serverless model, your cost floor is never zero. You always pay something for what you use. On that single machine that you already bought,
Adding a bit more work feels free because the cost is already sunk. It's just a totally different way of thinking about your economics.
So let's just quickly recap the three models. The single machine is simple, but it hits a hard wall. The multi-machine system grows with these chunky, expensive stair steps, and the serverless system gives you that smooth, linear, predictable cost. Each one has a completely different cost shape.
All right, we've been talking a lot about price, about what you pay on your cloud bill, but that's not the real cost, is it? To get the full picture, we need to go a little deeper.
I mean, when we say cost, what are we really talking about? It's not just the line item on an invoice. What else are we paying for?
Because the true cost, the total cost, includes all the human effort that goes into it. We're talking about the time spent on design, the engineering hours to build the thing, and all the ongoing, often complex work of debugging and maintenance. These costs are massive, and a lot of the time, they're hidden.
Think about it. That huge initial cost spike we saw with the multi-machine system, that's not just buying servers. That's thousands, maybe tens of thousands of engineering hours. When you use an existing serverless service, what you're really doing is outsourcing that massive upfront cost and complexity, which is why it's so often the right choice, especially when you're starting out.
So here's the takeaway. The next time you're in a meeting and someone throws around the word scalable, ask yourself, what's the shape of its cost curve? Is it a wall? Is it a staircase? Or is it a straight line? Because thinking in terms of constant marginal cost, that gives you an incredibly powerful tool for building better, more sustainable systems.